In 2024, GitHub found 29 million secrets sitting in plain text in public repositories. API keys, database passwords, cloud credentials, all of them real, all of them exploitable. And the scariest part, most of the developers who leak them have no idea. Welcome to AmtocSoft. Today we're tackling one of the most common and most preventable security disasters in software development, hard-coded credentials. By the end of this video, you'll understand exactly how secrets leak into your code, why deleting the file doesn't fix it, and how to set up a bulletproof system using free tools that catches mistakes before they ever reach GitHub. Whether you've been coding for 2 months or 2 years, this is the foundation of writing secure code. Let's get into it. First, what do we mean by secrets? A secret is any piece of data that grants access to a system and should never be shared publicly. API keys are the most common. When you sign up for Stripe, Twilio, OpenAI, or any cloud service, you get a key that authenticates your requests. That key is as powerful as your password. If someone has your OpenAI API key, they can run up your bill to thousands of dollars in hours. Database connection strings contain your username, password, and server address. Anyone with that string can connect to your database and read, modify, or delete your data. OAuth tokens and refresh tokens grant access to user accounts. SSH private keys let someone log into your servers. Cloud provider credentials for Oz, Azure, or GCP can spin up resources on your account or access your entire infrastructure. All of these need to be treated like the keys to your house. You wouldn't post your house key on Instagram, but developers accidentally post their API keys on GitHub every single day. Here's how it happens. A developer is building a feature that calls an external API. They need to test it locally, so they write the API key directly into the code. Just for now, they think, I'll move it to an environment variable later. Then they commit their code. Then they push to GitHub. And now that secret is permanently embedded in the repository's Git history. Here's the part most people don't understand. Even if you delete the file in the very next commit, the secret is still there. Git is a version control system. It keeps every version of every file forever. Anyone who clones your repo can run git log-p and scroll through every change ever made. The secret will be right there in the diff. GitHub's own analysis found that over 70% of leaked secrets remained valid for more than 48 hours after being pushed. Many stayed active for weeks because the developer never knew they were exposed. And it's not just Git push to a public repo. Secrets leak through Docker images, where build layers preserve environment variables even after deletion. They leak through CI/CD logs, where pipelines print environment variables during debugging. They leak through error messages and stack traces that include connection strings. They leak through shared Jupyter notebooks, through Slack messages, through screenshots of terminal output posted in support threads. The attack surface is enormous. This isn't theoretical. In 2022, attackers breached Uber's internal systems by finding hard-coded credentials in PowerShell scripts. The password was reportedly the literal string hardpass. From there, they pivoted into Uber's AWS environment and exposed data for 57 million users. Security researchers regularly find working Oz access keys baked into public Docker images on Docker Hub. The keys get embedded in image layers during the build process, and even deleting them in a later layer doesn't remove them from the image history. And in 2020, researchers found active API keys from Stripe, MailChimp, and Twilio in thousands of public GitHub repositories just by searching for common patterns like API_key equals. Many of these keys were still valid and gave full account access. The pattern is always the same. A developer takes a shortcut, Git remembers it forever, and someone eventually finds it. The first line of defense is dead simple. Never put secrets in your code. Use environment variables instead. Here's how it works. Instead of writing your API key directly in your Python file, you create a .env file in your project root. This file contains your actual secrets, one per line. OpenAI API key equals your key, database URL equals your connection string. Then in your code, you use the Python .env library to load these values at runtime. You import load.env and os, call load.env at the start of your application, and then read each secret with os.getEnv. Your actual code never contains the secret itself. It just reads it from the environment. The critical step, add .env to your .gitignore file. This tells Git to completely ignore the file, so it never gets committed, never gets pushed, and never enters the repository history. Create a .env.example file that shows the variable names without the actual values. This tells other developers which environment variables they need to set up without exposing any real credentials. Environment variables are great, but humans make mistakes. What if you accidentally paste a key into a comment or forget to add .env to gitignore? That's where GitLeaks comes in. GitLeaks is a free, open-source tool that scans your Git repository for secrets before they ever get pushed. You can install it with brew install GitLeaks on Mac or download it directly from GitHub. Run GitLeaks detect on any repository, and it will scan every commit in the history for patterns that look like API keys, passwords, tokens, and private keys. But the real power is using it as a pre-commit hook. A pre-commit hook runs automatically every time you try to commit code. If GitLeaks finds a secret in your stage changes, it blocks the commit and tells you exactly which file and line contains the problem. You fix it, and then commit again. This catches mistakes at the earliest possible moment, before they enter your local history, before they get pushed to a remote, and long before anyone else can see them. Setting it up takes about 2 minutes, and it runs invisibly in the background from that point forward. For teams and production systems, environment variables alone aren't enough. You need a centralized secrets manager. HashiCorp Vault and AWS Secrets Manager are the two most popular options. A secrets manager works like a secure vault with an API. Your applications authenticate to the vault at startup and request only the secrets they need. The secrets are delivered at runtime and never stored on disk. The vault handles rotation automatically. Instead of manually changing a database password across 20 services, the vault generates a new password, updates the database, and serves the new credential to every application that requests it. Your applications never know the rotation happened. Vault also provides detailed audit logs. You can see exactly which application accessed which secret and when. If a secret is compromised, you revoke it in one place, and every application automatically gets a fresh credential on its next request. For individual developers and small projects, .env files are perfectly fine. But as soon as you have a team, multiple environments, or production workloads, a secrets manager eliminates entire categories of risk. Five things to remember. Never put secrets directly in your code, not even for testing. Git remembers everything, so deleting a file doesn't delete the secret from history. Use .env files and .gitignore as your first line of defense. Install GitLeaks as a pre-commit hook to catch mistakes automatically. And for teams and production, use a secrets manager like Vault or Oz Secrets Manager. For the full deep dive with complete code examples for .env, GitLeaks, Vault, and AWS Secrets Manager, check out our blog post 29 million secrets leaked linked in the description below. If this video helped you write more secure code, hit subscribe and drop a comment. See you in the next one.